Okay, well, we're back with our part 4 of our series of video lectures on systems of equations of linear type, or in other words, solving multivariable linear equations. And we're going to be talking about, in the last video, we talked about Gauss-Jordan elimination technique by using matrices. And let's talk about some advantages of that particular technique. It's more compact in representing each stage of the solution. And while this is not a huge help for just maybe when you only have 2 equations or maybe 3 equations, when you start getting into 4 and 5 and 6 equations and multiple unknowns, then it becomes more and more crucial to keep track of everything. And the matrix method can really help us keep track of that. It is more compact in representing the information. It kind of eliminates having to rewrite all those x's and y's and z's or whatever your letters are for your variables. And notice that ultimately we came up with a consistent algorithm. And while there are some choices to make in that algorithm, and there are some alternatives to different ways of doing it, there's basically one set precise steps of things that we can do. And this algorithm can be made precise. And one thing you should maybe think about is, well, this requires us to put in a lot of data, organize it and store it, and to manipulate it. Well, that's something that calculators and computers are very good about. If we can identify the algorithm, we can program that into a calculator. Well, the good news is this is already built into your calculators. So this is probably the biggest advantage of this method, is that it is a method that we can program efficiently into a calculator, and it has already been programmed in. So let's take a look at working with matrices just a little bit on the calculator. And we're going to use a TI-84 and a TI-Nspire for examples. So to put matrices in a calculator, to put them in, the matrices are called matrix A, B, C, D, and so forth. There's a matrix button. It's the second button followed by the x inverse button, and so, or x to the negative 1 power button. That says matrix above it. You hit that. And to enter your matrices, go to here. Go to Edit, which you press either the left arrow once or the right arrow twice. Get to Edit. Select the matrix you want to enter, say A. And then you have to, the first thing it comes up with is this second screen here. It has 2 numbers here. The first number is the number of rows, and the second is the number of columns. As you put in numbers there, the size of this matrix down here changes. And then you simply fill in the blanks. And you can go around with your arrow keys and fill these in any order you want. But the easy way to do it is just like we read. Like this, you'd enter the 1, enter 3, enter 5, enter 6, enter. It takes you to the next row. 2, enter, 5, enter, 2, enter, 4, enter, 3, enter, 1, enter, 3, enter, 2, enter, 1, enter, 2, enter. And so you just put those in just like we would read, left to right down the page. Okay? When you're finished, put quit. Let me actually show you this with the calculator going here for a second. Okay, so let's put in a matrix. So matrix is right here, so it's blue, so you hit second matrix. And the first thing we want to do is go into edit a matrix, and let's put in one for matrix C. Enter. And we decide how big this wants to be. Looks like right now it's a 1 by 1 matrix, so it only has 1 entry in it. But we can make it whatever size we want. Let's say we've got 3 equations and 3 unknowns. So we'll have 3 rows. We'll have 3 rows because we have 3 equations. 4 columns because we have 3 unknowns plus the constants. Hit enter, and now this matrix now is the right size. And we can use our arrow keys and move around and change or enter any number we want. But let's say we enter some numbers here. I'm just going to kind of randomly type in some numbers. And when I get to the end of the matrix, after I put in my last one, then I want to hit quit, which is second quit. Now, I should always check to make sure I typed everything in right. So go to second, and then matrix again, and that was D, wasn't it? I think D or C. Anyway, whatever matrix I'm looking at, we can hit enter, and it will show us what we typed in. Actually, I think it was a different one, but it doesn't matter. The point is you can look at your matrix there. By the way, if we want matrix D, there is a bracket and a D and a bracket, but you can't get it by typing bracket D bracket. You have to get it from matrix and get it from the names. Okay. On the TI Nspire, here's a TI Nspire, we have a couple of different ways of putting the matrix in. One, we can go to Menu, Matrix and Vector, and then say Create, and just say Create a Matrix. Okay, and this one, it kind of tells us the number of rows. Let's say again we have 3 rows, and enter. Whoops, shouldn't hit enter. Matrix, create matrix. Should be down arrow. Let's see, up arrow. Let's make it 3 rows and tab. Gets you to the next one. Tab and 4 columns. Then hit OK, and it creates our matrix. And notice this one. This is more sophisticated. Even lets you put matrix inside of a matrix. We don't want that. We just want to delete this one here. There we go. Okay, so now we have our matrix and we type them in. Again, we should be able to put it in the same way. 3, enter. No, it won't let us. It won't let us do that. So we can. Probably gonna have to hit tab to go between. Yeah, hit tab, and it takes you to the next one. So hit tab between the entries in this one. Okay, and then when we get that in there, now if we want in the TI-84, you didn't really have a choice. You have to save. It's got to be saved under one of the built-in names, and you have several names there. Let's see how many of them are there. Looks like they go down through A through J, so there are 10 different names. Okay. In the Nspire, we can name it whatever we want if we want to store it. We don't even have to store it. We can just manipulate it like it is. But we can also store it somewhere. And so the store is up here, Control. Store. And then you give it a name. You can just type in a name. And I'm going to call it M1 for matrix 1. And so that's matrix 1. So I can, or M1. So I can refer to that later. In the Nspire, it's best if you try not to use single letter variables for names of things. So M1 for matrix 1 or whatever. Now there's another way to enter a matrix on the Nspire, and this also works on a TI-89 or a Voyage calculator as well. You can hit brackets. No, that was a parentheses. Control. Okay. Except I've got too many things going here. Okay, clear it out. Control here. All right, that's a bracket. And then that's going to be your matrix. And then for each row, enter another bracket and then within the row put commas between. So you can put another bracket here, and let's make a little short matrix here. 2, 3, 5, let's say, and then get out of that bracket, and then put another set of brackets and type in another one, 5, 1, 4. Notice I'm hitting a comma between each one. Oh, the 5 didn't take for some reason. There we go. And if we do that, this will give us a matrix where the first row is 2, 3, 5, and the second row is 5, 1, 4. Now when I hit enter, it's going to redo this. Even my entry is going to look like a regular matrix. And so it comes out like that. So that method works on a TI-89 or a Voyage calculator, TI Voyage, and also on the also works here. So you have a couple of different methods of entering them here. Okay, well, one of the things we want to be able to do is do some elementary row operations. And in fact, all three kinds of elementary row operations and more things that you can do to matrices are built in the calculators as well. So let's actually just do that. I want to do that on the let's start with the 84. Okay, so on the TI-84, let's say we have a matrix up here. Let's quit. I've got something stored as matrix. Well, I can just say take my matrix D that I just had here, and say I want to multiply row 1 by a half, which might be a thing I'd want to do to get a 1 there. Okay, so I can go to matrix, and go to math, and up arrow will get me there faster. And these last three, well, not that C is a row swap, E is a multiply constant, and F is our elimination step. So we're going to do the multiply row step. Okay, and the first thing you give it is the constant that you want to multiply by, a half. Then you give it the matrix you want to multiply by. Now I have two choices here. Since my previous answer was this matrix, I can just go second answer. Let's just do it that way for this time. So you just do it to my previous answer. Okay, and then let's see, what else do I want to do? I want to tell it which. I have to tell it which row. So row 1. So the syntax is the constant multiple, what the name of the matrix is, and which row you want to multiply by. So this should multiply that previous matrix by 1/2 in the first row, leave the second row and third row alone. If you look, that's exactly what it did. Now see the 3 dots? That means there's maybe more to see, so you can use your left or right arrow to see more, or up and down arrows possibly if it's a big enough matrix. So that's how we multiply a row. Now this matrix here is not stored anywhere. So if I want to store that back in D, for example, or E or F or something, I can hit store, answer, store, and then I go to matrix and find the name here. Let's store that answer in say whatever, F. So now F is this new matrix. Okay. What if I want to swap a couple of rows? So let's clear that out. Let's look at a matrix here. Let's go to the first matrix. What's matrix A? So there's matrix A. Okay, let's see. Let's do a smaller matrix here so we can see it all. Let's create a new one. So let's go to G, and let's make it 2 rows and 3 columns. So this would be like a 2 equations, 2 unknowns kind of situation. And let's say it started with the 0 there. And so your matrix would be it's number 7 here, G. So let's say that we have that matrix and we want to swap the rows. So we can swap row 1 and row 2. So that's matrix G. So again, we go to matrix, math, up arrow will get us there faster, and a row swap is C. Now if you know it's C, you can just do alpha C. And we can say row swap, and the syntax here is you give it the matrix. So I can go to matrix and say we want to use G, or I could have just said second answer since I already had it up there. And I want to swap row 1 and row 2. And it does that. Okay. Let's just go ahead and finish working this one out. So now I want to divide row 2 by 6. So I want to, and I can keep working with my previous answer. So I can go matrix, math, and I want to multiply a row by constant, so that's E. The constant I want to multiply is 1/6, and the matrix I want to use is my previous answer, and that's it. That's all there is to the row. Oh yeah, no, I have to tell which row. The row I want to do is row 2. There we go. So we want to multiply 1/6 by the matrix that we just had, second row only. And notice the first row should stay the same, and the second row is multiplied by 1/6. 3/6 is 0.5, and so forth. So that works out. Now we want to do an elimination step. We want to eliminate that 3. Okay, so to eliminate that 3, we want to multiply the second row by -3 and add it to row 1. So we go back to matrix, go to math, up arrow, that's our last one, F. Okay, so we do the constant multiple first, which is -3. Then we give it the matrix, which is just our previous answer. Then we give it which row we want to multiply by, which is the second row, and where we want the answer to be, which row we want to add it to, and which is the row 1, and the answer is also in row 1. So hopefully this is going to give us what we want. Yeah, let's check it out by hand. -3 times 0 is 0, plus 1 is 0. -3 times 1 is -3, plus 0 is 0. -3 times 0.5 is negative 1.5, and 6 plus -1.5 is 4.5. And so now we've solved that system of equations. So x is 4.5 and y is 0.5. We can also take our answer, remember, and change it to a fraction. And so x is 9/2 and y is 1/2. Okay, let's do the same thing in the Inspire. Okay, so in Inspire, again, you go to Menu, and we can go to Matrix, and let's say we want to do a row operation. They're all right here. Row add's not an elementary row operation, so the one we want is, we got swap row, multiply row, and so forth. So let's just do a swap row, and again, I can enter a matrix here with the different ways, but say one way we can enter a matrix is go here, matrix, create a matrix, and let's again do one with 2 rows, tab, and 3 columns. Okay, and let's enter it in, say 0, tab over, 2, 4, 5, 3, 7. So we're going to row swap on this. We want to row swap row 1 and 2. So should right arrow, okay, comma. We got to give it the 2 rows, 1 and 2. Okay, so this should row swap these. And sure enough it did. Now I'm going to manipulate my answer, so I'm going to take row 1 and multiply by 1/5. Okay, so menu, matrix, row operations, multiply row. And the order in this is exactly the same as this one as it was in the 84. So you give it what you want to multiply by first. Then you give it the matrix name, which in this case is just going to be the previous answer. And then the previous answer was control and then the minus sign for answer C. And then commas down here in the lower left on this particular keyboard layout. And then I tell it which row, which is row 1. Now I want to say do a similar thing for row 2 and get this to be a 1. So I want to do, again, menu, matrix and vector, row operations, multiply row. We want to multiply by 1/2. We want to multiply that by, for our answer, and only row 2 of that answer. Okay, that looks good. Final step is multiply row 2 by -3/5 and add to row 1. So let's see how to do that. Operation, row operation number 4. So row operation now we want to, okay, first of all, what are you going to multiply by? -3/5, comma, which matrix? The previous answer. Which row are we going to multiply by? Row 2. And we're going to add that answer to which row? Row 1, and the answer will be in row 1. Let's just double check this by hand. So -3/5 times 0 is 0 plus 1 is 1. -3/5 times 1 is -3/5. Plus 3/5 is 0, which is what we're trying to get. Okay, -3/5 times 2 is -6/5. Plus 7/5 is 1/5. And so we've solved that system. The system we had was, originally was 2y equals 4 and 5x plus 3y equals 7. And so we've solved it and say x is 1/5 and y is 2. Now, the really cool thing is you may have noticed this. This is awesome. There's a reduce row echelon form command right here, and it's called RREF for short. And you just put in a matrix here, and it can be a larger matrix if we want. So if we take a matrix with 4 rows and 5 columns and enter some stuff in. Let me just start randomly make up some numbers. Oh, I keep hitting enter. Enter works on the other calculator. Here I have to use tab. I'm just kind of randomly making up a problem here. And this is the coolest thing ever. Watch this. Boom. There's the answer. And it's all worked out. And on the Inspire, it does it in exact fraction arithmetic. And so there we go. There's x, there's y, there's z, or there's w, x, y, and z if you want to say, or x1, x2, x3, x4, whatever we want to call our variables. Isn't that slick? That is just so amazing. Think about how long it would take you to do a 4x4 system like this, 4 equations, 4 unknowns. It would take a lot of work. And now the cool thing is these can be fractions, these can be decimals, the arithmetic can be nasty, it doesn't matter. Boom, it does it. This can be as big a matrix as we want, and it still works out. If we wanted decimal approximations for that, then we can just say take our answer and do Control and enter, gives us decimal approximations for those. And so there we see it in exact fraction form for the answer and decimal approximations of those answers there. Now that is sweet. That is, just think about how tedious this is to do by hand. And now the calculator just does it. How about the TI-84? Yep, we can do the same thing here. I've got some matrices in here already. Let's take one. Take this one here, matrix C. So there's our matrix. Let's do a row reduce on that. Go to second, and then matrix. Right arrow to math. Up arrow, and if you look, B is RREF. You might even want to just memorize that as B. So you just do RREF. You can just say of my answer or of matrix C. And there it is. Now there's more, and this is, if you look here, that's the 100001001. That's what we want. So this is just X, Y, and Z here. And if we arrow over, so X is negative 1.573 with the 3 repeating, Y is 1.32, and Z is 0.96. Since these two are terminating decimals, and this one we can clearly see the repeating pattern, we do have exact answers. But normally we would like to have our exact answers as fractions. That's no problem either. Just hit math, enter, enter, and it gives our answers in fraction form. So X is negative 118 over 75, Y is 33 over 25, and Z is 24 over 25. Now how slick is that? That is just cool. Okay? And so that is a super, super duper time saver. Okay? Now in the slides you see some examples here of the row operations on the 84 and the Inspire, and the RREF on the calculator. You can see here, if it's a TI-83 or newer, it will definitely have the RREF. If you've only got a TI-82, you might want to borrow a TI-83 or something newer for the exam, because I don't think it has the RREF on the TI-82. Okay, there's the RREF involved on there. And then, so here are some for you to try it now. So now that you've seen it, solve these systems. Now, remember, you can use your calculator, so we can just use that RREF command. Depending on which calculator you have, you should be able to use that. So, press pause here, enter these in, get some answers, and we'll check them here in just a minute. Press pause now. Well, here's what it looks like. So the first one, I type in matrix A, go to matrix, then go to edit, and then say A, and type it in, and type these numbers in: 2.5, enter; 4.7, enter; 0.0066, enter; 10, enter; negative 15.35, enter, and so forth. When you get to the end, quit. And I always say do matrix names A and enter, and then look at your matrix, go left and right, up and down, and make sure you've typed everything in correctly, because you don't want to dismiss a problem just because there's a slight little typo or something. Very easy to happen. So once you're sure it's the right thing, do RREF of A. It'll do it in one step. It's just so cool. So just go matrix, right arrow to math under matrix, and then if you remember it's B, you can just go alpha B, and it'll go right to it. And then put parentheses. It'll open parentheses for you. You have to give it matrix A. If you've already got it in, you can just do entry second, and then enter as entry, or second and the minus button, I think. Anyway, it gives you to find the entry and do that, or you can go to names and get it as A. So you can go matrix names, the first one, A, enter, close parentheses, enter. And then you can also change that to a fraction if it will work out. Now, since this one had all these decimals, it's probably better to give a decimal answer. And this is an approximation, but it's probably way more digits that you're going to really need in a practical situation. You'll probably end up rounding that off at some point in any kind of practical situation. This really is not, however, an exact answer because these decimals, it does have a rational solution, but it will be something that is perhaps has repeating decimals in it, most likely, and we don't know how far out they go for the repeating pattern. So this is an approximation only, but plenty good enough for any kind of real-world situation. The next example, we have two equations but three unknowns. We have fewer equations than we do unknowns. So we know we're going to get infinitely many answers for this scenario. Graphically, this is two planes. Either the two planes are parallel and we don't get any answers at all, or the two planes intersect and we get a whole line of answers. Or they're the same plane twice, in which case you get a whole plane of answers. In this case, it's the case where they intersect. So I entered this matrix as B and did an RREF on B. And again, then I had to solve this. I think maybe I've still got this one in as B. Let's see here. Let's clear that. Matrix B. Let's see if that's the same one. 1.5. Yeah, that's right. So if you look up and down, 1.5 and negative 15.35. And if I right arrow over, let's just check everything to make sure this is all in there. Still in there like I had intended it before. Yeah, so that matrix is in there as B. And so now if I do RREF on that, so second matrix, right arrow to math, I can do alpha B, and then say matrix B, close parentheses, boom, there it is. Now, you can see by arrowing over what these numbers are. Now, remember, this is a system of equations. You might as well write z equals z, okay, but we can get x and y in terms of z. So remember, that's how we've been solving these. So it's a set of all x, y, z, which are elements of, and again, these are approximations, but close enough. So z is here, and then you're going to get, this is x plus this 0.0073z equals the 8.35, etc. And so that means x is negative 0.0073, etc. z plus 8.35, etc. And similarly, y is actually going to be the opposite of this guy right here, negative 0.003655 plus z plus the 0.1166 something. And so there we have our infinite solutions. Okay? And the next one, if you did this on the Inspire, if you entered these in fraction form rather than decimal, it'll come out with an exact fraction answer. But if you put it in decimals, it'll give you a decimal approximation. This next one, I can enter things in as fractions. I decided to do this one on the Inspire. You can see the matrix here and do RREF. One thing also on the Inspire, let me show you something that you can do on the Inspire. If you want, instead of remembering where the menu is, you can actually type in RREF, and that does work. And then put your matrix in. In fact, if you wanted to, you could put a matrix in like this. And this works just fine on the Voyage RTI-89 as well. So you can enter it like this. Oops. Oh, I need a matrix around the whole I need a matrix. I need another set of parentheses here. I can do Control X and then go back inside here and do Control V for copy and paste, the same as you use in Windows. So I needed that inside there to make that matrix work out. and so it will do that. So you can actually do everything without going through the menus there if you want to. The menus might be easier, this might be easier, depends. Actually fewer buttons if you go through the menus. Okay. Alright, back to the PowerPoint. Alright. And so that one turns out to be, here's exact fraction form there. And at least on the Inspire, it's going to give you that nice fraction answer. These are big enough denominators that it may be that the TI-83 or 84 would only give you decimals for that, and that's okay. Alright, now, the nice thing about this is, you know, in the previous ones, if we have, you know, you have decimals, you have fractions, you know, if you had to do this by hand, we'd be doing a lot of fraction arithmetic here, or a lot of decimal arithmetic. Or in the case of this last one, this is a huge system. No problem with the calculator. It takes you just a little bit longer to type it in and to be sure you got it all typed in correctly. But you're not even going to notice the difference in speed of how long it takes it to calculate. It's going to calculate that so fast. So go ahead and try these now. We've got 3 different systems to do here. A system of 3 equations here, E is a system of 3, and then F is a system of 5 equations and 5 unknowns. Okay? Press pause. Come back when you're done. Okay, and here's what we get for answers. Something interesting happened on this first one. Notice that right here, even when I tried to change it to a fraction or in decimal, the x and y coordinates here came out, or x and z's came out nicely in fractions. But for the y, I get 1.9 e negative something, at least 13, or maybe bigger than that. I can't tell. I'd have to go to the right here. But the point is this is a point and a whole bunch of zeros. This one, that means the y-coordinate is approximately 0. Well, it turns out the y-coordinate's exactly 0. This is a little bit of a round-off error in the calculator where it came up close to 0 but not exactly on. In actuality, it is exactly on. So you might test it with it being exactly 0, especially if these others turn out to be nice fraction answers, and test it out. But if you actually check this, negative 9/2, 0, 19/3, I checked it out, and sure enough, it checks out perfectly when this is exactly 0. So in actuality, it's exactly 0, not approximately 0. And then, but the Inspire actually gives you the 0, the correct exact value for 0, and the exact fractions for the others. And the next one, you know, here's a decimal version. You get after RREF, and then you can change to fraction. So here's a nice exact fraction value here. And I did the last one on the Inspire, just kind of going back and forth a little bit. And the last one works pretty nicely on either one. Here's the exact answer. It's a little bit too big to fit on one screen, but you can see the first and the second. So you can see the, I guess it's V and W, because I did V, W, X, Y, Z. So this is V, this is W. There's W again, and then there's X, Y, and Z. And there they are in approximations in decimal form. So the exact values of these fractions right here and the decimal approximations are that. They're approximations. Even if I give all the digits this calculator has, they're only approximations. The exact values are the fraction ones. So that completes our overview of how to use the calculator on whether it's a TI Inspire or whether it is a TI-84 or similar calculator. And the other TI calculators work a very similar way. Some of your other brands, you'll have to figure out how to work those if you have a different brand, but they should work somewhat similar manner to what we saw here. And this is very, very cool stuff, because the real power of the Gauss-Jordan method is that it can be programmed into a calculator, and that's totally cool, because now we can use that built-in calculator program to solve these, particularly when it's a nasty big, nasty coefficients or lots of equations to mess with. No problem, just get it in that calculator and we can work it out. We'll come back in our next video and we'll have a short video where we'll do a few applications. And so we'll see you then.